Hey guys, so in this video we are going to see how to limit the frog movement so that the frog does not go out of the screen. So let me just show you. We need to add some code. If you on the last video with the code that we added, the frog was able to get out of the screen and then come back, and we don't want that. So we need to limit the frog movement so it doesn't go lower than this row right here. It cannot go out from the right or the left of the screen, or it cannot go out from the top. So cannot. In this case, it's going out from the top, but it's because when the frog reaches these houses right here, it's gonna stop moving, so we don't have that problem. So now I'm gonna show you how to limit the movement, and we're gonna start by limiting the frog movement so it doesn't go lower than the second row, and it doesn't go out from the left or the right. And it's really simple. Basically what we need to do is that we are only going to move the frog when the X position or the Y position is within a certain range. So you can see, for example, here, left position, I'm doing a condition when I'm saying, okay, if the X position of the frog is greater than 16, then we can move left. And why we have this 16 here? Well, basically because the frog can move. Let me put the frog here at the bottom. So the frog can move, and now you can see that the frog is not aligned with the grid, because since the frog is starting exactly in the middle of the game, it doesn't get aligned, and so when it's moving, and it's moving 32 pixels by 32, when it's moving, so it's never going to be aligned. So at the end, what we are going to do is limit the frog not with a 32 grid, not a 32 by 32 grid, but with a 16 by 16, which is this green grid that I activated here. So we are going to let the frog move to the left until it reaches this position. And this position here, remember that the top left corner of the image is the actual position of the actor. So the X position here is 16 because it's at 16 units from the left. So we can only move the frog to the left when the X position is greater than 16. When the frog reaches here, we don't allow this to run anymore. Right is exactly the same thing, so it's not 16, but it's going to be, so the frog would be here. And remember that it's not, the position is on the top left corner. So right here, what we have is that our game screen has 448 pixels of width. So the rightmost position that the frog can have is 448 minus 16 minus 32, which gives us like 400. And down, exactly the same thing. So I'm going to put the frog back in the middle. Down is exactly the same thing. So we have 512 minus 32 minus 32. So 512 minus 64 is 448. So we can only move the frog down if y is less than 448, which is exactly here. This is like the limit. And this is the way to limit the frog moving to the left, to the right, and to the bottom. And to the and to the top, pretty similar. So you can see that I'm using if y greater than 96, and then I have some other thing here that I'll go into it in just a minute. But let's just forget this for a minute. Let me just remove these ones. Okay, so if y is greater than 96, and 96, y is 96. Let me just activate the other grid. So initially, just to explain you what I tried to do first. Initially, I thought, okay, so the frog can move up, and we have collisions set up to all these tiles. So I just want the frog to move to inside the house. So the frog won't be able to move up from this row right here. And this row, top leftmost is here, so 32, 32. So the frog could move until its position is greater than 64, which is exactly when the frog is at this line. And I tried this at first, but this was assuming that the collisions that I had in place for all the other the tiles would work, but they don't work. Let me just show you. So this is what I went with the first time, but it doesn't work, and it's because of the movement that we are using with our frog. So you can see it comes here, so it cannot go up. So we are limiting the movement to the 64, which is the first two rows. But it doesn't care about anything else, so it can just move through the walls and everything. So the collisions that we had in place, and remember that we on the last video we saw how to add the collisions here. So you can see that, for example, this one has a square collision. So I was hoping that, okay, so we have a collision in place, so I can limit the movement so the frog does not go up from this line, but all the other tiles have collisions, so it will just stop the frog movement from going inside this green part right here. But the collisions don't work, and I think it's because since we are not moving the frog like smoothly, we are not moving the frog on frame by frame. So the frog is not, the position is not x equals 1, 2, 3, 4, and the frog is moving like this. We are taking the frog and just jumping the frog from 32 pixels to 32 pixels. This, what this makes is that the collision is not detected. So when the frog is here and jumps here, the collision bound that is defined for the tile is not colliding with the frog, because the frog is not moving into the collision bound. It's just jumping from here to on top of the tile, and that the collision is not detected. I tried different ways to solve this. I tried to increase the collision of the frog, because if you go to our frog, you have here the collision. You can see where do I have to me. You can see that when you import the animations, the frog already also has like a collision, in this case a square collision. And I thought, okay, maybe if I increase the collision of the frog, so when we are on that tile, the collision will detect the collision with the other tile, and so we cannot move afterwards. But it doesn't work as well, because I think since we are once again just jumping from a tile to tile, the collision is not detected because we are not moving the frog smoothly through the different positions. So it didn't work. Then I thought about using regions. And regions is another concept that I'm not going into it right now, because I ended up not using them. But I tried to use regions, and the logic behind it was the same that I ended up using, but without the regions. So what I thought about was like, okay, maybe if these collisions here are not working, so what I'm gonna do is that, okay, I'm gonna limit the movement of the frog to this row right here. So the frog cannot go over from this line right here, and then I'm only gonna let the frog move up when it's at the entrance of each one of the houses. So by default, the frog cannot move up from this line, but if it is at the entrance of any of these houses, then it can move up once again. And the first thought I think was, okay, I can use regions, and regions you have it here. I think, yeah, region box. It's just something that you can create in your scene. And it's like an area that gives you a warning or gives you an event when the actor is inside the region. So I thought, okay, I'm going to make a region here. Not like this, but maybe like this on the entrance. I can scale it here, I don't know. On the entrance, so I know, okay, the frog is inside the region, which is an entrance for the house, and when the frog is inside the region, I can let it move up. So I'm just going to ignore the other limitation that I had. But I couldn't get regions to work, to be honest, so I have to come back to regions later. And it was also like a lot of trouble to what I want to do, because it's not that hard to know when the frog is at the entrance of each one of the houses, because we know the exact position of each one of the houses, and we are moving inside a grid, so we know exactly when the frog is at that exact position. So for example here, the first house, and if I enable the other grid, the 16 by 16 grid, you can see that the frog is at the entrance of this house when its X position, and we don't need to worry about the Y, because this is going to only be applied to the up position. So it's not a problem. So we know that the frog is at the entrance of this house when the X position is equal to 16, which you can see that it is half of the first tile. And this one is going to be 16 plus 96, which is 3 tiles to the right, and again and again and again. So we know exactly the position that the frog is when it's at the entrance of the house. So we can use that position and just say, okay, we know that the frog is at the entrance when its x position is equal to any one of these values. So I thought, okay, now I know the values, so I can use them to know when the frog is at the entrance of those houses. I'm going to just change this to 96, don't forget, because 64 was to limit the frog would come here, 96 the frog will stay here. And so I thought, okay, now I have 5 different values, one value for the entrance of each house, that I need to use to compare with the x position of the frog, so to know if it is at any one of these entrances. So I said, okay, I can create either 5 variables. I need to store these values anywhere. I mean, I can compare them by hand, saying, okay, if the x position is equal to 16, or if x position is equal to another one, or if x position is equal to the other one, and I have like a really big condition, with OR operators. Then I thought, okay, this is not really efficient, and it's really hard to read that big condition. So I thought, okay, I'm going to store these 5 values, and then I'm going to compare the x position of the frog with each one of the values. And if I have a match with any of those values, then it means that the frog is at the entrance of one of the houses. And so I thought, okay, I need to store 5 values. If I need to store 5 values, I cannot use a variable, like a normal variable, let's call it like this. I mean, I could use 5 variables, one for each one of the values, or I can use a list. And just like Scratch, Stencyl also has lists. So here in the attributes, you have lists, and you can also come here to the attributes. If you add a new attribute, you have a list type for your attribute. And remember that a variable allows you to store a single value, a list allows you to store multiple values under one name. That's exactly what you want. So I ended up creating a new attribute that I called entrances of type list. It's hidden, just like the other one. And you can see that here, this window here changes according to the type of the variable that you created. And here I have a list, and I added all the values for each one of the entrances. So this is the entrance for the first house, the second, third, fourth, and fifth house. So now that I have a list with all the values, I can use this list to compare the x position of the frog with each one of the values. And how can I do that? And I ended up using another functionality that Stencyl has and Scratch doesn't have, and it's really awesome, which is to create your own blocks. I mean, Scratch, you can create your own blocks, but it's not that easy to create your own blocks, at least from my experience. And this one is more advanced in that way. And you can create your own blocks and add your own code to the blocks, and just use the blocks anywhere you want. So I create my own block, which is this one. You can see like custom. Here on the custom, you have this block, actor is at any entrance. So this is a block that I created specific for this behavior. And how do you create a custom block? Add event, advanced, custom block. It's gonna create a new event. You can see it here, called custom block, and you can create. And here you give the name of your block. So I don't know, custom, whatever. The block field, I won't go into this right now. We're gonna do it on later, because I'm gonna use more custom blocks for sure. The specification is what appears here. So what kind of text appears here, and you can see that how the block will look, and you have a sample like hill, and you have like the %0 by %1. And this %0, the 0 and the 1, is basically a reference to the block fields. So in this case, when we use %0, it's going to appear here as the first field, which is an actor. All the custom blocks have an actor, but you can add other ones. So you can like do something like, okay, actor, custom block, whatever. And you also have a return type. And what's a return type? A return type basically is that when you use one of the blocks might have, you can just use the block and the block doesn't have any value, does not return any value, or the block can return you a value. And that value you can define here on the return type. And for example, in this case, the block that I'm using is what? I'm creating a block that says that if the frog is at any of the entrances that I defined. So that block, if I'm using the block to know if the frog is at any of the entrances, so the block will return, okay, the frog is at one of the entrances, it will return true, or it will return false. So when I'm using this block, which is exactly what I did, so the return type of my block is a Boolean, which makes that when I use this block when it's running, it runs the code that's inside, and at the end, this block will be an actual value of true or false. So I can use this block as a true or false. And that's what the return type does when you create your own blocks. If this block returned a number, then I could use the block as if it was a number, or as if it was a text, or as if it was the value that it is returning. That's what the return type does. And so I'm not going to use here the custom block. I already have mine. So I created this block. I called it is at entrance. You can see it here. Is inside any entrance. This is a customization that I did. So %0 is at any entrance and returns a Boolean. So this block, when I'm using this block, you can look at it at this block is either a true or a false. It depends what it runs inside. So before going to the code in the actual block, I can use this block, like I said, like a Boolean value, and so I can combine this block with an OR operator, and the condition is exactly this one. So if the Y position is greater than 96, is when I can move the frog up, or if the frog is inside any entrance, then I can also move the frog up. So this overrides the other condition, because this condition will run the code that's inside if any of the conditions that it's inside the OR is true. So if this is true or this is true, then we can run this. So what happened is that when the frog is here, the position is not greater than 96. So this is false, but the frog is inside an entrance. And so this is true, and the entire condition is true. That's how the OR block works. And now let's see the code that I'm using inside the custom block that I just created. So let me just deconstruct this block right here. So the block runs, and what I'm doing is that, remember that I stored all the values of the entrances inside a list. And so what I need to do here is that I'm going to take the X position of the frog and compare the X position with each one of these values. And when I have a match, when the X position is equal to one of these values, then it means that the frog is inside the entrance, and I can return true. So first thing, how can I go over all these values right here? Basically what I need to do is use a repeat block. So I'm going to repeat the code that's inside this block. How many times? I'm going to repeat that code as many times as the number of items that I have on the list. So in this case, 5. And when you use a repeat block, you have this new variable that is created. It's like an internal variable for this loop, for this block, which is a current loop count. And what is the current loop count? So since you are repeating this block, the current loop count starts at 0. It runs one time, and then the current loop count is 1, runs a second time, and then it's 2, it's 3, it's 4, and how many times that you run it. And why is this useful? Because the current loop count matches exactly the index of each one of the values that you store inside the list. So when you store values inside the list, each value has an index. So the first value that you store inside the list has an index of a number of 0. The other one has a number of 1, 2, 3, 4. So forth. So the current loop count will match exactly the value that's inside the list. And this is really useful because you're going to repeat the first time, and the first time you can use this block get item number, in this case 0, from the list. So when you run the first time, you can get item number 0. When you run the second time, you can get item number 1, and so forth until the end of the list. And this is how you iterate the list and then use the values that are inside the list to do whatever you want with them. And here, what we are doing is that we are running this inside. Let's move this. So what we are doing is this condition that if the X position of the frog is equal to the item number from the list, then it means that the frog is at the entrance. So let's see how this works if we are running this code. We start the repeat block. We have 5 items on the entrances, and the current loop count is equal to 0. The first time that we run, so if the position of the frog is equal to get item 0 from entrances, which is 16, it gives me the value of 16. So if the X position of the frog is equal to 16, then we return true, which means that the frog is at the entrance or is at the first entrance. But if it's not, then the loop continues, goes back to the beginning. The current loop is now 1, and we go back to the same code. So if the X position of the frog is equal to get number 1 from entrances, and number 1 is 1/12, and if it's true, return true. If it's not, it continues. And the loop will continue, seeing if we have a match between the X position of the frog and any of these values that we store in the list. And if we have a match, we return true. If we don't have a match with any of the values, then this repeat block will run entirely, we'll reach the end, and at the end of our custom block, we return false. Remember, because if you are returning a value, when you create a custom block and you are returning a value, you need to return that value on any path that you have inside your block. So I cannot end the block and not return a false, because whoever is calling or using this block inside the rest of the game is expecting a Boolean value. So this block always results in a true or false value. You need to return true or false anywhere on the block until the block ends, or before the block ends. You cannot end the block without returning anything. Only if you define a custom block that does not return anything. And this is a really important concept. I'm talking about blocks and using blocks and returning values. And this is a really important concept because this is what translates into functions in code. So functions are basically this. Functions are blocks of instructions. These are blocks of code where you can add many instructions that you can call anywhere in your code and that can or not return a value. And a custom block is basically what the translation to block coding of a function in actual coding, which is pretty awesome, to be honest. And so this is the code to see if the frog is at any entrance. And then on the up, I can say, okay, if the Y position is greater than 96 or if the actor is inside any entrance. And remember that this block, when we are running the code, this block basically represents a true or a false value. And so this is it. I mean, now if I run the code, you can see that we are limiting the frog on the third line from the top, but when the frog reaches any of the entrances, then it can continue moving up. So if I come here, I cannot move up, and it seems or gives the illusion that the frog is actually colliding with the wall, but it is not. This is basically a limit in terms of the position. This is this limit working. But when we are inside an entrance, so we are inside an entrance which is right here, I can move up. Oh, but then I cannot move left. Oh, but it's not a problem, yeah. So forget it. It's not a problem because as soon as the frog reaches here, we are going to reset the frog position to the beginning and just change, add a sprite here that the frog arrived and that the house is already filled. So we don't need to worry about that. So the frog right now can just go off the screen and come back. So this is not a problem. So, and this is it. I mean, this video has some complex concepts, at least I think so. This concept of using functions is rather complex. We have lists, we are iterating through the lists. There are some more, some complex concepts here, but I'm really sure that we are going to go back to all these concepts throughout the rest of the development of the game. So if it's not entirely clear, don't worry, because I'm positive that we are going to go back to these concepts on later videos. So this is it. Thanks, guys.